Enhancing large language model performance in auditing through Retrieval-Augmented Generation, integrating frame-specific knowledge for tabular data processing. Okay, next. First, I want to give you a very brief introduction to the background. The large language models in accounting and auditing has already have a rapid evaluation and adoptions in the business world. The key milestones of large language models, there's three of them. The first one is when Vashvani developed the transformer architecture for natural language processing. Then people started to explore large language model. Then in 2020, OpenAI released their GPT-3, and people become pretty aware of large language model. Later, in 2022, ChatGPT, that's also developed by OpenAI, launched a demonstrate. Then they launched demonstrates practical applications, and from that time, AI, the large language models in AI become very popular, and people from different industries starting adopt large language model in their own field. And large language model has captured attention from both accounting and academics and industry practitioners, leading to the widespread integration efforts into routine accounting and auditing flows. And those application has already shown great potential for business task assist in accounting and auditing domain. And here's one thing I want to clarify before I start is, in my article, we mention a lot of times the foundation large language model. The definition of that is a pre-trained models like GPT-4, Claude, Llama, those language models trained on a board of dataset without domain-specific customization. That is, the Bloomberg models, they are not considered as a foundation large language model in this article. And these foundation large language models has demonstrated capabilities in language proficiency, visual recognition, and some level of reasoning. Since we've already have some foundation large language models, what's the reason we start this research? This is because there are some limitations of this foundation large language model in profession contests. You may heard about some news like a lawyer used ChatGPT to generate their appeal. However, ChatGPT gives them some cases that never exists. That's a problem of foundation large language model in knowledge deficiencies. Since those large language models are trained on the general dataset without firm-specific procedures or regulatory guidance in some specific industry, it can generate seemingly credible but incorrect response. That's what we call hallucinations. And it also limits this kind of general datasets as a trained dataset, also limits the reasoning capability for domain-specific tasks. We've already find some evidence in legal service, in finance, and even in health. Hallucination has become a very big problem. All the companies trying to solve those problems. Although the foundation large language models like GPT-4 are improving on those hallucination problems, they still make many mistakes when you trying to use them. And the introduction of this research. The primary objective of this paper is propose a conceptual framework and showcase a RAG enhanced. RAG is Retrieval-Augmented Generation enhanced large language model designed explicitly for auditing procedures that integrate tabular data and textual reasoning capabilities. And another motivation of this research is a attention limitation of large language model and memory degradation. The first, the sentence PM attention limitation. The models struggle to maintain focus across extended context and complex multiple state process. First, let me explain what it is. Think about when you are talking to ChatGPT, you say one sentence, you ask a question, ChatGPT give you an answer, you ask another one, ChatGPT give you another answer. When those conversation extended, ChatGPT will gradually forget your first questions or the beginning contents you given to the ChatGPT. That's what we call the extended contents. And complex multiple state process. As Maher showed, ChatGPT and those foundation large language models, they just follow a sequential path directly. You ask a question, they give you an answer. They do not have the multiple state, like have multiple large language model agents run run together, run parallelly. So every time you ask ChatGPT a question, you only have one agent, one large language model to run it. So those kind of foundation large language model has limitation in complex multiple state process. Because of this attention limitation, a problem of memory degradation exists. That's a gradual loss of task-specific instructions as model forgets the previous uploaded documents over time. I see something in chat box. Okay. And so also as a result, it reduces the reliability when you use a foundation large language model in a specific domain. It can lead to inconsistent performance for complex auditing procedures, requiring sustained attention and consistency. More specific, in tabular data processing, it has more weakness. The first one is relationship recognition. It cannot understand the connection between the spreadsheets, rows, and columns due to the limited contextual attention. And when you combine the reasoning together with the calculation accuracy decreased. So there's a kind of inconsistent numerical computations and formula application across large data set. The last thing is multi-documents integration, as we mentioned in the last slides. Foundation large language model keep forgetting some documents upload to them, so it cannot synchronize the information across related tabular files due to the memory degradations. And I also want to show you what kind of tabular data are there we test in the research. This is a general audit worksheet, and you can see it's actually an Excel file. What the auditors need to do is they need to input some summaries, like as an unstructured texts. Like, what are they used? Why they make such judgments? At the same time, they need to record copies of numbers and figures from other documents, put them in the right place, and do calculation. Then they also need to describe and test objectives, describe sampling units, describe how the company is.
So when you talk about memory degradation and associated problems, couldn't they be alleviated somewhat by increasing the token budget?
Yes, yes, it is.
So in a way, there is a solution. You actually just need to throw more compute at it, right? And somehow I understand it's not gonna eliminate the problem, but it can alleviate it.
Yes, that's true. You can always extend the tokens to record all the questions you asked in that in your conversation between you and AI. And you can also extend the tokens to put all the documents for the AI, but that could be much more expensive compared to use a rack system.
Do you have any numbers comparing these approaches?
We didn't try to put all of them as a token, but in this research, we run the trials. We ask for more than, let me think, 1,600 questions. Including the trials we're using, the experiments, and the amount we develop, we use less than $50 to build all of these systems. And since the audit worksheet is a mixture between the unstructured data, the numbers from different document source, calculation, and summarization, the AI can handle those massive interpretive work better than those rule-based systems. So unlike RPA and macro automation, which excel at rule-based calculation, RAG AI provides intelligent interpretation of unstructured audit narratives and generates context summaries that require professional judgments. This is an advantage of using large language model compared to using the rule-based system. Now I'm going to talk about a little bit technology details of RAG, Retrieval-Augmented Generations. What is RAG? RAG is a technology that enables large language model to access external knowledge database and retrieve relevant information through automated search methods. The key advantage of it is a practical middle ground between prompt engineering and fine-tuning. Prompt engineering by users, I think most of you should be very familiar with that. That's when you ask AI questions, you follow kind of patterns. And if the users have to follow the prompt engineering every time when interact with the AI, it takes the users longer time and more cognitive burdens. That's the difference between RAG and prompt engineering. Also, the previous comments I got is, why not use fine-tuning? Fine-tuning is, first, when you fine-tuning is adjust the foundation large language model itself with some specific domain data. However, fine-tuning needs the data has a very high quality. It also needs very large data set. At the same time, train a fine-tuning model is much expensive than use RAG directly. So we think here, RAG is between prompt engineering. We put all the responsibilities to the users, and fine-tuning, where we give all the burdens to the developers of the large language model. It enhances accuracy by incorporating external knowledge without modifying the base models and without a lot of efforts of the users. And here is a figure. You can see what's the difference between retrieval-augmented generations and foundation large language models. Here is the foundation large language models. When you provide files, documents to large language models, users upload their prompts, query, and documents to the user's interface, and the files will be chunked into small pieces, sent together with prompt and query to the large language model endpoint. Then the endpoint generates context and give it back to user. This is pretty direct process. That's what we have in foundation large language model. And with RAG, what we have is we only need the users to put their questions as prompt and query. Then the user's interface will query the RAG by using the external knowledge source. That's where we upload the documents. It will search, the system will search the relevant information and retrieve the related documents from the knowledge source and send all these informations, the retrieval informations together with the user's prompt and query to the large language model endpoints. That's step 4. And large language model endpoints will send the generated text back to the customers. In summary, the differences here in the foundation large language models, that's the user who provides the documents, but in the RAG enhanced system, the system itself search for the knowledge source and find the relevant documents and contents. Then how does RAG work? How RAG works, 4-stage process. This is how we build the RAG. The first stage is document pre-processing. First, we need to convert the documents into vector representations. The second stage is query vectorizations. That's transform users' queries into vector form. Then similarity-based retrieval. That's find the matching document segments in the vector spaces. That is match the second step contents with the first step contents. The last step is combine the retrieval information with LLM to generate the responses. Theoretically, this is what we need to do, but in Maher's hand-on exercise, you can see some of the platform, they have built a very user-friendly way for you to build a RAG system. What you need to do is upload the documents, set some parameters, then connect it to your AI workflow. You don't need to calculate the vector representations yourself. It has already done by those AI agent platforms.
My question is about stage 4.
Yes.
So when you say combine retrieved information with LLM, I cannot pretend to be anywhere close to being an expert, and maybe it's due to my ignorance. but the impression that I currently have is that what happens at this stage actually is that the retrieved information becomes part of the an add-on to the prompt.
Yes.
So essentially, whatever you add after finding in this RAG data source will consume a part of your token budget.
Yes, that's true. So, but that's true. But those knowledge database here, when it search the relevant information, it doesn't use a whole knowledge source. It's just following kind of.
No, I understand. You have those previous steps, so it
Yes.
finds the closest one. So in that searching in the vector space, but after it retrieves it, that it becomes a part of the prompt.
Yeah, that's true. But
And the size of the prompt and the context that it maintains during this interaction with an LLM, right?
yeah,
How
yeah,
much you can do that depends on your token budget. That
yes.
and of course on the say how much you're paying for compute and the deployed capabilities of the LLM. So again, when you're comparing those things, I mean, I think it should be made clear. Thank you.
Okay. Yeah, we have a log how much tokens we use, but because I set up this research to compare the accuracy, but I can definitely pull out those how the token data, the token usage information, and compare it to the full large language model. Okay, and on a higher level, how to develop the RAG enhanced large language model for tabular data processing in auditing. This first prepare the data and convert the format into kind of machine readable format. We also recommend the TXT textual format because that will be more clear for machine to read it. Then develop a knowledge database and retrieval-augmented generations. That's where you upload the files, set up the chunk size, and length. The third step is build a workflow. You connect the user's input box with RAG, and you connect those prompts together to a large language model. That's build the workflow like this. We have a rack here. We've already cleaned all the data in this rack, and we have a start where we take the user's input. Then we use rack to combine the user's prompt together with the retrieval information to large language model and get large language model to generate the output and send it back to the users. Then the case study in tabular data processing. In this research, we use 160 auditing procedure profiles obtained from a US-based auditing firm. And the foundation model we use is GPT-4o. The prompt, when we set up prompts inside the system, we follow the CoStar framework. That's context, objective, structure, task-specific details, adaptability, and relevance. And this is how the RAG enhanced chatbot looks like. When users ask questions, it answers. When users put the numbers, the auditing procedures related numbers, those users do not to specific identify which documents the chatbot need to use, but the chatbot will point out which documents are relevant to the question and do calculation. In the evaluation of the research, we set up 4 different audit tasks. And for each task, we have 10 test cases. I think it's here. For example, in a audit sampling test case, we set up 10 test case. We give this information as an input, and this is expected output as our ground truth. And for each audit task, we run 4 trials to test the stability of the system. And the large language model system setting, the first one is minimal file access setting. That's where we use ChatGPT-4 directly, provide 1 or 3 specific files required for tabular data processing task. This setting represents a baseline condition with a minimal necessary documents. The documents are not uploaded directly to the large language model. So we use this setting to mimic how the auditors deal with the documents if they use ChatGPT directly. And the auditors should know clearly what documents they are going to use. And we have our second setting, maximal capacity setting, where we also use GPT-4o with a membership. But this time we randomly select some irrelevant auditing procedure files up to the platform with a maximum limit of 10 files together with a required file. And in this case, we want to test if the auditor only know, okay, the information I need is within these 10 files, but I don't know which file exactly that is. When we provide this bunch of files to the large language model, can large language model, the foundation model, directly find what information is necessary? That's the setting of maximal capacity setting. The third one is RAG enhanced setting, where we use complete knowledge. The baseline RAG, so we define a baseline RAG. In our experiment, the baseline RAG implementations are connected to all 160 documents in the auditing procedures knowledge base. And here is one specific example. This is a prompt we use as a user. Okay. Please be aware that this is just a prompt we use as a user, not a prompt in the system. The steps to finish the auditing task is the auditors first need to do the initial calculation, then do comparison based on what condition it is. The auditors follow the different rules to do another calculation or summarization. The third step is consideration of remaining balance. Auditors need to record, document what they have done, and decide what they need to do next. Then if the testing more individual, whether the auditors need to testing more individual significant items, then do documentation and make the summary of their decision on the further testing. This is a real example what auditors need to do for one auditing task. And this is a result we get when we use ChatGPT-4o with only the necessary file provided For low complexity tasks, the accuracy is quite high. But when we increase the complexity of the tasks, the accuracy dropped immediately. And when we provide the necessary files together with some random files as ChatGPT maximum, the average, even for the low complexity, is less than 50%. And when we increase the complexity, it's still pretty low. But after we use RAG, we didn't do any adjustment. It's just a RAG system connect the database. The average accuracy of the low complexity task is 83%. Medium complexity is even higher, 75%, 87%. And for high complexity, ChatGPT doesn't do good work in either minimal or maximal. The average accuracy is below 40%, and the baseline RAG still remain 83.75% accuracy. And when we mix the low, medium, and high complexity tasks together, we form a mixed task. The mixed tasks, the average of ChatGPTs are low. However, the baseline RAG is still above 80%. We also test the stability with 4 trials, and we can see ChatGPT is pretty stable when the task complexity is very low. But after we increase the complexity of those tasks, the foundation large language models becomes unstable. But baseline RAG remains pretty stable in all the stage. We also have additional tests on graph RAGs as a more advanced RAG system. We do expect a better performance with interconnected documents. However, when we compare the performance of graph RAG and baseline RAG, we find out the baseline RAG outperformed than the graph RAG in accuracy and stability. So we think one explanation is the tabular data calculation typically contained within a single document. That's why we may not need graph RAG. Or another reason is because graph RAG is more complex than the baseline RAG, added complexity without corresponding benefits for the audit workflows. And we are thinking maybe when we use a more advanced RAG system, we should also improve the AI agent workflow to achieve better accuracy, but that's not included in this research. The key research contribution includes we prove a framework, the RAG enhanced system achieved more than 80% accuracy versus 40% for the foundation large language models. Although this kind of framework has already been proved in the computer science areas and many other fields, auditing is a little bit special because the auditing worksheet is a mixture between calculation, reasoning, summarization. They use both structured data and unstructured data. But in this research, we've already find the evidence that the RAG also works for auditing worksheet. And we find a practical solution, the cost-effective implementation for small, medium audit firms. Because compared to fine-tuning, which has a much more requirement on the resources, the RAG, this type of methods is a cost-effective method, and it also increases the accuracy. And we also found the empirical evidence that baseline RAG optimal for auditing tabular data processing. That's the end of my presentation and questions or comments, Professor Kogan.
Yes. So your results are based on GPT-4o as the
Yes.
foundation model.
Yes.
Now, have you tried working, say, with other foundation models across a number of different vendors to see if the results are robust? So DeepSeek is publicly available. Among the models that more directly compete with OpenAI, Claude 4.0, probably Opus, if not then Sonnet, maybe another interesting case for comparison, just to see. Essentially, you're saying that according to you, so RAG doubles the accuracy, roughly, right?
Yeah. Yes. That's
So,
a
so does it depend on a particular large language model? So this kind of relationship, can it be expected with other models? So even if you go completely, say you're talking about large, small, medium firms, so open source, so DeepSeek is open weights, so open source is Llama. Again, there are newer versions of Llama, different size models. Would that show similar results? Or so what are you going to expect with different models? By the way, even with GPT, 4.5 is available. They still promise 5.0 by the end of the year, but this is a very, very quickly changing landscape, right, of the large language model. So my question essentially is whether your results are specific to GPT-4o, or if you have any evidence to claim any kind of robustness of results across a universe of LLMs.
Yes, I think we can definitely include the robustness test there, because we derived those experiments last year in October. At that time, I don't think the DeepSeek comes at that time. That's when
DeepSeek came out, well, V3 came out in late December. R1, the reasoning counterpart,
yes.
became available in mid-January.
Okay, yeah. So when we do all those trials, that was October 2024. So, and at that time, we do some pilot tests to compare the different models, include Claude um and what and
Llama.
Gemini and ChatGPT 4o, and we didn't find many difference. So we just select one, the most popular one at that time, GPT-4o, to start this experiment. But since it's already July 2025, that's 8 months after the initial experiment, I think we can add some additional test in this research at the as a robustness test there. Sure.
Okay, thank you.
Thank you. And let's see some questions in the chat.
Fangbing,
Yes.
one of our audience asked, did you also use DeFi to create the RAG enhanced system?
I think you can explain this, because what's the relationship between the hand-on exercise and the research? From Xiaomei, I learned actually I had a meeting with Maher yesterday. The purpose of the hand-on exercise of this seminar is to let the audience know how to develop the system in the research. The relationship is actually we have the research first, then we design the exercise for you to understand how to build the technology methodologies. in the research. So we use DeFi.